Okay. So we are now in our next chapter, chapter 7, right? So what you guys just completed online was getting you through counting atoms. We're going to have a small section about that at the end of this, okay? All right. So for chemical reactions, all right, a chemical reaction is just going to be a process in which one or more substances are changed to new substances, right? We learned this at the beginning of the year. It was a chemical change, all right? All right, we had signs of a chemical change. They were things like giving off of heat and light. So if we had a temperature change or we saw light, it was showing that energy was given off. We had production of a gas. What form do we usually see that in? You guys remember? In a liquid? I think sodas.
Oh,
yeah.
I totally know what you're talking about.
Uh-huh. All right, bubbles. Bubbles, you guys. We're going to be looking for things like bubbles. Okay, so bubbles form. We do have formation of a precipitate. Okay, which is not the same as precipitation. Okay, nope, it's actually, so precipitation is actually something liquidy. This is solid. This is a solid that forms and settles out of solution. So we mix two liquids together and we end up forming a solid, and it looks milky at first, and then it kind of, if you wait till the end of the day, it usually settles down to the bottom of your test tube. All right, or we have color change. So those are all our indications that we're going to be looking for, especially in all of our labs in this chapter, okay? All right, we also have, well, we do have our parts of a chemical reaction, right? So, and today we're going to really go through the writing the chemical equations, just what are the different symbols used. You guys have a quick exit ticket after it, okay? So parts of your chemical reaction, the main event is you got reactants versus the products. So our reactants are the original substances. And products are going to be the new substances, the things that are created. Okay? Hold on. In the reactants, they are also known as stuff like ingredients. You can kind of think of them that way. But what's more important is the reactants are usually on the left-hand side of the arrow. The products are on the right-hand side. It always points to the products. Arrows always point to the products, okay? So whether you have an arrow going the opposite direction, it's pointing at the products always. What was your question?
Second assignment, when do we have to?
Right after this. Okay. All right. So writing your chemical equations. A chemical equation is just a shorthand expression. So that means that we're going to use symbols to kind of represent what's going on. Okay? Shorthand expression describing that chemical reaction. You must use correct formulas. Okay? I emphasize that because that means everything you learned in chapter 5 and 6, where you took names and you had to make formulas out of them, now you actually really got to use it because you can't have the wrong formula. All right? You have to use correct formulas. So a couple tips about that. The diatomics, and that one you guys aren't super familiar with yet, so now it's official, you got to know it, okay? So that's that green poster that's above the fume hood over here. That's our diatomic 7, okay? So when these guys are by themselves, they have to be doubled, meaning they have to have a subscript of a little 2. So that would be hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Now, you look at that and you're like, how am I supposed to memorize those, Miss Fogel? You don't. You look at a periodic table, and you will remember them because they make a 7 on your periodic table. So hydrogen is over here. We all know where hydrogen is on our periodic table. But then starting at nitrogen, you're going to go across to fluorine and down to iodine, and that makes a 7 on your periodic table on the right-hand side. Okay, and that'll be kind of how you know or kind of remember it a little bit, right? You don't have to have them memorized. You just got to know to make sure you double them when you do see them, okay? So in case you're like totally lost of what I was saying, here's nitrogen. You make a 7 all the way down to iodine, okay? Just make a 7. And then hydrogen is included. All right, the other elements you use correct formulas, chemical symbols. And follow the rules for writing formulas. So let's take a second to write a couple hints underneath that. So your formulas, remember we've learned in the past, in chapter 5 we learned we take our charges and we cross and drop. Some of you guys did not master that. Now you have to. You absolutely have to. When you're recombining things, you got to take their charges. That little cheat sheet that you guys have had in here, now is a great time to start using it and getting used to it. Okay? Take those charges, cross and drop. You know that you have Roman numerals, and those represent your different charges that are also going to cross and drop. I'm sorry, I'm writing that really small. Okay. You also have polyatomics. Those are inside your periodic table. We also had prefixes. Who did we use the prefixes for again? Ionic or covalent? Covalent. Covalent. All right. So covalent, monodiatri. That tells you the subscript to put down there. Okay. So again, if you didn't quite master chapter 5, now you really have to. So if we need to do tutoring, please let me know, or go back to the old videos and watch them. All right. Okay, so it's really important that we're doing that. Now let's talk about kind of what was in the assignment that you just did while I was across the way. A subscript. Okay, so a subscript were the things that form after we cross and drop, right? We take our charges, cross and drop, or we take our prefixes and we put the subscripts. These tell how many atoms you have of each element. You never, ever, ever change them. Once you've established them, once you've done cross and drop, once you've put them in because of what the name of that compound is, you have to leave the subscripts alone. Okay, so something like H2O, this is your subscript. What's the subscript on oxygen right here? 1, exactly. We don't write 1, right? Okay, so never touch your subscripts. You're going to want to. All right, a coefficient, go away please, tells the number of moles of each substance. You can put molecules right above it, okay? Because you guys don't know what moles are yet. We're going to learn that one too. Good. Sweet. No, this is different. We'll get there. Don't worry about it. But what I'm trying to get you guys to see on this is that when we ask you for how many carbon dioxide molecules there are, you're looking at coefficients. You're not looking at little subscripts anymore, okay? So this is always written in front of our formula used to balance equations. Dina Fogel. Hey. No. She's an 8. Okay. Okay. Bye. Okay. All right. So it's used to balance equations. That's going to be something that you guys are going to be messing with a lot. That's the thing that you're going to change, not the subscripts. All right. Our couple equation symbols that we got to learn. So produces, yields, or forms. That's just going to be an arrow. Okay. Yields is what it's called. This is a yield sign. Not to be confused with driving yield signs. It's not the same thing. So this means produces. All right. Plus reacts with or combines with is a plus symbol. That's easy. So that means reacts with, right? Or as a product, it means that you're making more than one product. So and. All right. If a reaction is reversible, you're going to see this symbol instead of an arrow that goes only one direction. You're going to see an arrow that goes both directions, forward and backwards. We may or may not hit a chapter called equilibrium, and that's where that'll show up a lot. But just in case you do happen to see one like that, that's what it means. And then heat is added to reactant. That's going to be an arrow and a little triangle sitting on top of it. Okay? So heat added to reactants. Add a little note that it could also be a spark. What was something that we did that needed a spark to get something going in one of our old labs? Fire, yeah, the Bunsen burner, right? We had to use the little striker to get it to go. That would be where we would use this little triangle. All right. So these over here, these are going to be kind of important. You're going to write the symbols right here, and then I'm going to add a couple things to kind of help you with when to put them, all right? Because people kind of get confused at this part. So solid will be a lowercase s. Liquid will be a cursive L. Gas will be a lowercase g. Aqueous will be a lowercase aq. Okay? Now, yes, if we say solid this, gaseous that, aqueous that, it's pretty easy. And you're like, yeah, I can do that. Woo, sweet. But when we're asking you to basically put these symbols when you see them in your lab, like where you see how they actually are, it's going to be important to kind of keep these straight. So solids can usually be a metal by itself, so like magnesium, and ionic solids or ionic salts. Okay? It's not limited to that though, okay? So you can also see sulfur, carbon. Carbon tends to, as a reactant, tends to be a solid. You'll see that. All right, liquid. This is the one everyone screws up. It's always misused. You are only going to use liquid for things like water or a pure substance. Now, question. If everything that you mix in chemistry is a solution, is that a pure substance or is that a mixture? A solution. So a solution, a saltwater solution, is that a mixture or pure substance? It's a mixture, which means you will not be using it for most of the things that you're going to be mixing together in here. We don't use liquid, except I would say for the most part, water. As soon as you see water, put liquid, okay? There's an exception to that, but don't worry about it. All right, gas. All right, so a good one to remember for this is going to be your diatomics. Otherwise, you'll kind of just get used to the normal gases. So carbon dioxide, oxygen gas. Oh, oxygen gas would be good too. You'll see them, okay? A lot of your covalent stuff is going to definitely be solid. All right, aqueous. So like I said, aqueous, this means it's mixed in water. Or it's dissolved in water, right? That means it's all of your solutions. Put a star next to this because when in doubt, put aqueous because most likely that's what it is for chemistry. Okay?